So we're now at the final class of this spring's Aquatic Academy. In the first three classes, you heard from some of the world's great ocean explorers. And tonight you're going to hear from the man who made it possible for all of us to become ocean explorers. And his partner in crime will be arriving here probably in another 15 minutes. These guys literally started in a garage, and they developed an ROV. You can buy it in a kit for about $900 and assemble it. We used one here last summer, and he's going to tell you all about this and some other things. David and his colleague Eric Stackpole, engineer at NASA, pioneered the development of small, inexpensive ROVs. And their goal initially was to get rich. They thought they were going to strike gold. And he'll tell you the story of they didn't find the gold, but they may have found something even much more valuable for all of the rest of us. And he's a self-taught sailor. He grew up in Minnesota. I don't think he sailed in all 10,000 lakes or whatever. And he heard about that Eric Stackpole was building a small, cheap, robust submarine in his garage, and he was the guy that first had the idea of going looking for this gold that had been stolen by some Native Americans, hidden in a cave. They never had a chance to go back because they were caught and hanged. They've been back a few times. They haven't been caught or hanged, but they haven't found the gold either. They founded Open ROV, which is a wonderful company, open source hardware. It belongs in the DIY community, the do-it-yourself community. It takes part. It's an important part of the makers movement, and they've been stimulating that. David is a TED Fellow. He has given 2 TED Talks, and he participated in the first and so far the only forum of U.S. explorers that has ever been held, and it was held at this aquarium in July of 2013. And so we're going to hear from David, and maybe Eric will weigh in on a few things. And then following that, we're going to have the world premiere of a new film that has been created by the aquarium. It's called Perspectives on Ocean Exploration. And this is the very first time it will have ever been seen by a public audience. Benjamin Weiss, who's over there and hunkered down, he doesn't want to acknowledge who he is until we see how we react to the film. And it was our AV crew, particularly Andrew Cohen, that worked so much with Ben in producing this film. And so we'll talk more about that before the film is shown. So let's start with that short video that we have that was taken here at the aquarium of Open ROV last summer, and then we'll have David come up and he's going to talk to you. So maybe you can narrate this.
So this was, I remember this. Is this the YouTube video or is this the video you guys have?
I think.
Okay, so Jerry was kind enough to let us drive the ROV swimming Jerry was kind enough to let us try and actually fly this thing where we had no idea how that was going to go. So this was quite an experiment, actually. And it was a lot of fun. So at this time, Eric and Colin and a couple other folks were on the top driving the ROV, and I was down in the behind the glass with all of the people, and I was trying to explain to them what was going on. I didn't really know what they were doing, so I was all improvising, kind of like I'm doing right now. If anything, they're actually curious about it. You can see the kids absolutely loved it. that was something that was very apparent as soon as we put these things in the water. Kids love these little underwater robots, and they treat them almost as if they want to pet them and treat them as pets. It's kind of strange. The other thing about this was at this exact moment, on the screen behind where this was going on, there was an Okeanos dive. So there was NOAA was out with one of their big ROVs showing video from where they were diving. I forget what trench or what they were exploring, but it was very cool to see what NOAA was doing out in the deep ocean and be able to point behind the glass and say, that's a smaller version of what they're doing. And I think it helped a lot of, especially the kids, draw parallels and say, oh, okay, so this is the kind of technology that we're using to go out and explore the oceans. And it made it something that seemed all of a sudden a little bit more tangible. So those are the battery packs. I'll show you a little photo of how this thing is configured in a second.
Champions for citizen science, and we're going to be working further with David. There's a meeting going on in San Diego of the Ocean Exploration Advisory Board, which is the most important advisory board for ocean exploration in this country. They met today, and he drove up after it ended, and he has to go back down there tonight because it meets again tomorrow. So be kind to him, Bob. All right.
All right. So what is an ROV? ROV stands for remotely operated vehicle. To put it really simply, it's a camera that has a thin tether going back up to the surface, and you can drive it around from your computer and see what the robot is seeing. So you don't have to dive down and actually go in. It's a way to be there without actually being there. It's got a few thrusters, so it's got 3 thrusters, 2 in the back that make it go forward and reverse and left and right, 1 that helps it go up and down. There's batteries on board, there's small miniature Linux computers, and there's lights and lasers, and we've made that all into a kit that we sell to people all over the world. Here's a quick shot of it underwater with its lights on, looking for shipwrecks, doing what it does best. So, like I said, I'm not an engineer, I'm not a scientist, just a regular guy. And this story did, in fact, start as a search for gold. And Eric told me the story, and it really is a fantastic story, and maybe you'll have to grab him afterwards and try and get him to tell you. There was a few sites on the internet. There was an old newspaper clipping, and the rumor was that there was treasure at the bottom of this cave that was from a gold rush, and all these treasure hunters had tried to go and get it, and these scuba divers, and no one had been able to get to the bottom of the cave. But Eric said, I have an idea. I want to build an underwater robot to go and explore. And he pulled this thing on the table and showed it to me, and I was blown away. I thought, this is so exciting. And it was, at the time in my life, I didn't have a job. Actually, I did have a job. I was sitting in an office writing a lot of emails, working for a company, and I thought, this sounds like an adventure. I want to be a part of it. And so what I did is I said, Eric, you'll have to let me tag along. I'll just write about this and try and learn and help as much as I can. And Eric said, okay, sure. And we both kind of didn't know what we were doing. So we put up a website and said, this project is open source. This is called Open ROV. We're building an underwater robot, and we need your help to do it. And we asked the internet for help. And for many, many months, that was me asking Eric questions about physics and electronics, and it was just me and him on the forums until we got written about in the New York Times, and all of a sudden, more people found out about us, and it just kind of slowly, we got more and more people who knew about what we were doing, and I think took pity on how little progress we were making. And so people started to contribute, and we ended up getting a robot that we could actually go back to the cave and explore. And we did that. And it was quite a thrill. It was just like straight out of the Goonies. And then we put the project on Kickstarter. So we started hearing from people from all over the world. They said, hey, I've got this cave. Their metaphorical cave. They had whatever they wanted to explore, and they wanted to build their own underwater robot. So we decided to put it on Kickstarter, and we were asking for $20,000. We thought that was a lot of money at the time because neither of us had any money. We still don't have any money. But we put this project on Kickstarter, and I thought, wow, that'd be cool if we were able to make our goal. We ended up meeting that goal in about 3 hours, which was exciting. You see these numbers going up, and you're like, whoa, this is a lot of fun, and we're high-fiving, and then you realize, oh, wow, we really got to make a lot of robots. And then the real work begins. So we had promised these kits, and then all of a sudden these boxes start showing up, and you really have to do all of the work, and it's quite a bit. But we managed to figure it out. We had some friends show up and help us, and we eventually started a company, and we were able to ship out those Kickstarter robots, and in the past 2 years, we've shipped close to 1,500 more. So we're one of the largest underwater robot manufacturers in the world. We have 10 employees in a small company. It's just pretty amazing. It's still, I laugh every time I say it because it's still amazing to me. And these things are going all over the world, which is the most exciting part. In Florida and cenotes in Mexico and Antarctica and silky sharks in the Caribbean, and it's spread all over. But the real story here, I think, is that it's not just us. Is that what we're doing is actually a small part of a much bigger story. And you can look around and you can see other ocean instruments like this. You can see people taking these Raspberry Pis, which are small miniature Linux computers, and turning them into buoys and their own kind of autonomous vehicles. And what's happening is the maker movement. So all of these people who are using 3D printers and different digital fabrication tools and maker spaces are going out and saying, hey, well, if I have all these tools, I can just make my own tools for science and exploration and conservation. And that's exactly what's happening. Here's a CTD device. I think this group is still making progress. Walt thinks he's going to beat them to the punch on actually making a functioning device. Here's another story. This is a friend of mine, Chris Anderson, who took this picture, actually was playing around with his kids in their backyard about, I think it was like 5 or 6 years ago. And they had this model plane, and they also had a Lego Mindstorms kit, and they thought, hey, we could basically make an autopilot for this plane using these toys. And so they started toying around with this idea. They ended up creating a website called DIY Drones, very similar to what Open ROV was, just kind of asking other people to get involved. And they ended up coming up with kits for drones, and they've since grown into this really big company, and they're manufacturing these drones. How many people have seen one of these drones flying around or heard of all of these low-cost drones before? I mean, it's almost hard to turn on the TV without hearing about these things. And 5 years ago, these didn't exist. I mean, these low-cost tools for doing this kind of work, it just wasn't available. And now it's available at a price point that's really exciting. And it's also, the capability is getting to the point where these can be used for really, really interesting things. Not just for taking videos of surfers, but there's also all sorts of really interesting applications for conservation and science. And people are doing this for monitoring endangered species. People are doing this for protecting against deforestation in Indonesia. It's happening all over, and it's just one example of these tools for science exploration and conservation that have gotten much cheaper over the past few years. It's a very, very recent thing. This is another story I like to tell because it's much closer to home. You might recognize that garage, that was actually the same garage. It was Eric's garage that Open ROV got started in, that I had in that other picture with all those boxes. And so these were his roommates at the time. Eric, did you take this picture? So somebody took this picture of these guys in their garage, and they had a similar idea to Eric and I. They said, all of these tools, all of this computing is getting so cheap. Everybody has a smartphone in their pocket, I think, maybe. If you don't, that's amazing. And the sensors are getting so cheap. The computing, the sensors, the cameras. And they thought, well, maybe we could use these tools to make little micro satellites. And that's exactly what they did. So they have since gone from a garage to launching, I don't know, how many satellites have they launched now? So they have 74 satellites in orbit. These are microsatellites. They're getting images of every location on Earth every day, or they will soon, and they're running a space program from their office in San Francisco, I think. I don't know if they're a billion-dollar company, but they're soon to be a billion-dollar company. These were Eric's roommates. They started at the same garage that we did. That's a kind of an extreme example, but it gives you a sense of where we are in time. That the technology is changing so fast that it's causing the tools and the capabilities to change really, really fast as well. And these are some images that they've gotten. They picked up a forest fire just before anybody else had it. So some really amazing stories that are starting to come from this Earth imaging network that these guys are creating. And so I'll just run through a few more examples. This is a group in Borneo who's monitoring their rainforest using those DIY drones. There's now a 50-cent, another friend of ours is making origami microscopes that cost 50 cents to make, which is it's an amazing feat. And it's given rise to this whole community of people on microcosmos.foldscope.com who are now sharing. Yeah, it's called the Foldscope, sorry. And there are now tens of thousands of people who are sharing their experiments and their explorations of the microcosmos online, who are asking questions that are really, really interesting. Probably wouldn't get an NSF grant to do these things, but they're really interesting questions. And now, because the tools are so cheap, anybody can ask them. And you can, most importantly, you can kind of share them with the community and get feedback on what you're asking. So after the nuclear reactor meltdown in Fukushima, a group of makers and hackers got together to create SafeCast, where they built their own Geiger counters and went around and actually mapped the impact of the meltdown in real time. That project is called SafeCast, again, using these low-cost tools. There's now these spaces called DIY biolabs, where there's these community spaces where you can go and make your own engineered microbes. And these DIY biologists, these garage biologists, are now competing in international design competitions with their engineered microbes. It's really exciting and interesting and really kind of weird stuff. This group, they're friends of ours. They're making real vegan cheese. It's pretty amazing what they're trying to do. And they're also building these new tools that are much lower cost and powering these growing number of garage wet labs, which is really, really an exciting and interesting trend. And anyways, I could go on and on. There's a huge, long list of examples of these new maker tools that 5 years ago didn't exist, now being used for science and exploration and conservation in really novel and innovative ways. And so this whole thing, this whole trend, doesn't have a good name yet. And Jerry and I were just talking about this at dinner. So citizen science gets thrown around a lot. And how many people have heard the term citizen science before? And you might be like me, where you think, okay, well, this means that I'm going to go out and collect data for somebody's research and volunteer. And that's fine. That's interesting. I've done it before. I like it. But to me, the story that I just told you is very different than that idea. The story that I'm trying to tell, that we're trying to tell, that we think is happening right now is much bigger than that. And I like this. I drew this little graph because I think this is happening. This amateur curiosity is just exploding. You no longer need an NSF grant. You no longer need to be a doctorate in ocean science to ask a question and to go out and find the answer. And that's really just a thrill. And nobody realizes it yet. You guys in the room, you guys all have the secret now. You guys are ahead of the game. So this is not the last story I'm going to tell, but this is another one I want to point out. This is one of my big heroes in life. He just passed away last year. His name was John Dobson. And he'll be best remembered for the Dobsonian telescope, which is a design you'll see. That's the design right there. It's a kind of novel way of mounting larger lenses using whatever materials. You could use wood, you can use cardboard, whatever you have lying around. It was a really innovative idea that he came up with. He wasn't an engineer, he wasn't a scientist, he was actually a monk. And he got kicked out of the monastery in the 60s because his telescope building hobby had just gotten out of control. And he spent the rest of his life standing on street corners, sleeping inside telescopes, and just inviting everyone who passed by to look up into the stars. And he showed them how to build their own telescopes, and never patented his design or try to make money off it, just wanted more people involved. And it's actually his telescope. This was one of the major reasons that amateurs have been able to make so many important contributions to the field of astronomy. It's this and the internet are basically, and the star parties, he kind of created this culture around amateur astronomy that did exist a longer time ago, but kind of rejuvenated in past years, and he was a big reason for that. And so I look at him as a model. And I've been calling this new trend connected exploration. I don't know if that's a good term. If you guys like it, you're welcome to use it. But if you have a better idea, please tell me. But this idea of low-cost DIY tools, an internet connection, and this community of collaboration. So low-cost sensors, open standards, and connected enthusiasm is really powering what I hope could be a new era of exploration, which is not just about 10 National Geographic explorers who are going to go around the world to cool places and make documentaries and tell us about it. That's fine that they get to do that. I hope they keep doing that. But I think it's a really unfortunate narrative that people think that this world has been explored and there's nothing left to explore and we know everything about it, because that's not the case at all. And what I've been trying to tell people is that it's actually you folks, the people who are interested and curious, can actually be a part of this. And if we all start telling the same story, it can become a movement in the same way that the maker movement has come about. So I told you, it started with literally two guys working in a garage with something that kind of worked. And now it's become this thing that is much, much bigger than us. And about 6 months ago, 8 months ago, we started a site called Open Explorer. It was designed as a digital field journal to give our community a way to share, not just what we were building together, but what we were exploring together as well. And in that short amount of time, we've seen discovery of shipwrecks in Australia and pursuit of lost Incan cities in Peru. And beyond the underwater realm as well, we've seen a field biologist who's building an internet-connected rover to study desert tortoises in the Mojave. It's interesting. And this group who just got back, this is a wild story. It's a group of makers and scientists who were in the jungle in Madagascar with soldering irons and microcontrollers, really pushing the limits and the boundaries of remote sensing. So you can go to openexplorer.com and you can see it's weird stuff, honestly. It's pretty feral. But it's interesting. And I think what you can see there is a community that's getting smarter together. And the fact of the matter is, when you ask a question, even if at the beginning it's kind of a dumb question, if you stick with it long enough, eventually it'll become interesting. And I think what's happening right now is there's this group education going on among this new class of amateur explorers. And I'm excited to see where it ends up. That's all I have.
We're going to look at this film. It's about 36 minutes long. And then after the film, we're going to talk about it. and get your ideas. It's another part of what this aquarium is doing to try to make the case for ocean exploration. It started with that forum that we did in July of 2013. That was to be the first annual. The second one has not occurred. We're told it will probably occur in November of this year at the National Aquarium. This course was part of that overall effort to make the case for ocean exploration. This film is another piece of it. Those portraits that you see hanging in the Great Hall are going to be made into a book. We're going to add, we have the support for it. We're adding 5 other explorers, and Zofia, the artist, is painting their portraits. She'll begin doing that within a week or 2. And so that book becomes another part of this, and we're going to continue to try to make a compelling case for ocean exploration. And so when we're all done with this, then we will have some discussion. This was the current state that it is in was as of about, what, 5 o'clock this afternoon, Ben? More like 6:30. 6:30, okay, 6:30. And so we'll talk about what's going to happen after tonight, and we'll get your thoughts. So let's get the lights off, and if we can roll it. The world ocean is the largest component of Earth's living infrastructure, her life support system for all life on Earth. In the near future, we will look to the ocean for more food, more medicine, more energy, both renewable and non-renewable, for more shipping and transportation, for more recreation, and for more inspiration. We are changing the world ocean in ways and at rates inconceivable as recently as only a decade or 2 ago. And yet, less than 10% of the world ocean has ever been explored. There is an urgency and an opportunity and a responsibility. In 2013, the Aquarium of the Pacific was asked by NOAA to convene with them the first ever gathering of U.S. ocean explorers. This report, Ocean Exploration 2020, resulted from that forum. The film you are about to see provides perspectives by some of the nation's leading ocean explorers on the importance of ocean exploration.
You know, it's really funny. I think when you talk to most people, they think the age of exploration is in our rearview mirror. It's something that occurred in the 17th and 1800s. And yet, in fact, it's in our future.
We did a great deal of oceanography in the deep water, in the northern half of this planet, in the North Atlantic and the North Pacific, all during World War II and during the Cold War. Virtually nothing in the southern hemisphere, and not much in the shallow areas. But we created a great database of information and some great understanding about general trends in the ocean. Yet we still have only explored less than 5% of the ocean.
But I come back to this idea of if I was a space traveler from some other planet arriving on Earth, I wouldn't come and land on land to find out what's normal, because the first impression I would get is, well, clearly most of the volume of this planet, most of the habitable space is the ocean.
I mean, that's an answer why it's important. We haven't gone there yet. We've done a lot of work, but such an enormous place and so complex. And if we're going to understand how our planet works, we have to understand the world ocean.
The largest contiguous joined up space for living in is the Pacific Ocean. And it's the least explored part of the planet.
When I was a kid, it was all about outer space. It was going where no man has gone before, in galaxies far, far away. And I think now it's tackling inner space for the benefit of humanity. That's what I'd call ocean exploration.
How could we not explore the ocean? How could we not want to know everything we possibly can find out about how this living system functions and what we're doing to it, so that we have a chance of securing an enduring future for us?
It's fundamental to life on this manned satellite we call planet Earth.
The ocean is really the source of life on this planet. It's the source of heat. It's the source of our weather, our climate. And the more we could understand about the ocean and ocean processes, the more we understand about the position of man within this large system.
In exploration, you're just saying, wow, nobody's been here, humans haven't looked, and there'll be amazing phenomena. Now, there aren't always amazing phenomena, but enough of the time in the oceans there is. So ocean exploration, it's scouting. It's going out to the frontier.
It wouldn't be stupid for me to devote the rest of my career just to exploring the Pacific Ocean and finding out what else is down there. Because there's probably a lot of stuff we don't even know about yet. So it's very hard for me to articulate why do we need to go do this, because I don't know what's down there that's important.
There's research that has been done in the Marianas Trench aboard Falkor that recently discovered extraordinary levels of biological activity in the deepest part of the ocean, busier there than anywhere in the water deeper than 6,500 feet. What's going on? Is this part of the system? Is this part of the life cycle of the ocean?
As people get more increasingly concerned about how do we sustain the planet, are we worried about whether we're damaging it or not, how do you understand what impact you're having if you don't understand the natural system to start with? And how do you understand a natural system where the largest habitable space is the least explored space we've got?
In the last century, we have caused more change to the chemistry of the planet than it's ever seen. The ocean is acidifying at a rate 10 times faster than at any period known before 50 million years ago. It's very much connected to us. And the point of exploration is, oh, it's really interesting. Look, we found a new species, that's great. But what does it add to our body of knowledge about the system? That we have to connect between the land and the oceans.
In my mind, exploration has to do with understanding what are the new questions out there in the ocean that we have not yet been able to look into, and that we may want to look into and research and further understand to gain knowledge about our environment. So it doesn't have to do with answering any particular questions, but it has to do with understanding what questions are still out there for us to understand.
I would define exploration as venturing into the unknown, trying to make discoveries. You can't ever guarantee there will be discoveries to be made, but the ocean is pretty amazing. If you start looking in places you haven't looked before, you tend to usually discover something.
I guess a lot of people know, the statistic that 70% of the Earth is covered with water. The one that I'm more impressed by is that more than half the Earth is covered by water that's more than 2 miles deep. So the deep ocean is actually what's normal for our planet.
Clearly, exploration is an early stage of research. In general, it's the qualitative stage when you try and define what it's all about. Research, you're trying to put numbers on it.
Ocean research is where scientists have a reasonably good hypothesis that they want to go and test. They have a working model of what they think it is, and then they want to go out and test that model. Basic exploration is quite honestly going where you've never been, where you really don't know. If I look back on my career of 56 years of going to sea and 160 expeditions, the ones that were the most important ones was when I went looking for one thing and found something far more important.
The scientific research end of it really picks up on the discovery end and tries to understand the why and the where and the how.
Scientific research has to do with focusing on particular questions that exist out there to improve our understanding of certain phenomena, or understand the causes or the processes that we kind of have known about before but don't fully understand. Exploration has to do with finding new questions, new phenomena, new events that we have not observed in the past, and we will need to understand better to gain knowledge about the oceans.
Sometimes people try and ask the question, well, what's the difference between exploration and research? As though it's a black and white thing. My answer is, actually, it's a grey scale, that one evolves into the other. Exploration isn't always just wandering off wildly into the blue going, I wonder what I'm going to find, or I wonder if there's anything interesting to be found here. In some of the work I do, for example, in hydrothermal exploration, it was just a simple thing, like I grew up being taught that you could have hydrothermal vents in the Pacific Ocean where the volcanic chain is very active, and the Atlantic was much less active, so there shouldn't be any hydrothermal vents there. And I didn't believe it. And I said, well, but the rock types are the same in both places. So the Atlantic may be less active, but it has to erupt sometime because those rocks are there and they're volcanic rocks. And on the day they erupt, if they're that composition, then they must erupt at that temperature. And when they're that hot, sitting at the bottom of the ocean, and the ocean's about the same temperature in the Atlantic and the Pacific, the same chemical reactions should take place. It may be harder to find them. You may not just stumble upon them as easily as you can in the Pacific, but if you go and look carefully, there's no reason why they shouldn't be there.
You think of something and you develop maybe a hypothesis to try and explain it. Then you have to do the experiment. In case of the Explorer, you're curious about something out in the world, and you may have some idea of what it is, or maybe based on previous explorations, but when you go out, you're just sort of filling in a lot of blanks. And as you fill in these blanks and develop information about what you're looking at, then it soon migrates into a scientific research project. It's not admissible that the explorer and the scientist are the same person. In fact, it's very common.
You can think of research as being somewhat more formalized and laboratory-oriented, but my research is mostly using the ocean as a laboratory. I too, in the ocean, set up objectives, try to prove or disprove an idea, but it involves just jumping in to places where no one has ever been to find out what's there. You have to look at the terrain underwater or above, and before you can begin to figure out what your questions are, to test ideas. So, am I an explorer? Oh yes. Am I a researcher? Well, yes. So it comes together seamlessly.
It's a spectrum. You can't make a wall between exploration and research. They're all part of one thing. But exploration is the square one.
I love science, I do science, I am a scientist, but the essence of science is controlled experiment. You have Earth and twin Earth, or you have a numerical model, and you do tests, and you say, I expect the result to be that I'll find a school of 100 mackerel, but instead I found 100 anchovies.
And that's one of the things that's really important. I always try and stress to students and things like that is there's nothing wrong with the data. If an experiment doesn't work out the way you expect it to, then that's a good thing. The days when things don't work the way you expect them to are actually the best days in science, because that's when you found out something new. If you have a hypothesis, the worst thing I could ever imagine happening was I went out on a research cruise and I found exactly what I expected to find.
You take many more chances. If you're a PhD student and you tackle something that is not understood, it may not work out. There's a problem as to what risk you're willing to have. I received a very nice award from the Japanese, the Kyoto Prize, and gave the money to Scripps for the purpose of making that fund available to students who are willing to take risk and look at a problem that may not work out.
The panel on ocean exploration, President Clinton's panel on ocean exploration, was a gathering of a group of people, of ocean explorers, ocean experts, who I think recognized that the current way in which we were doing ocean science, which was really what we call hypothesis-driven, you'd write a proposal to test a hypothesis, was not the only answer to ocean science. That the state of our understanding of the ocean was probably still at a level that there was much, much more room for discovery. And so we collectively tried to come up with a program that would put that discovery and exploration back into the mix. Most sciences evolve very quickly to a hypothesis-driven process where you test a hypothesis. It's a scientific method. But sometimes when you're dealing with something like the ocean, and we have only a few % of it mapped, it's a little premature to say everything has to be hypothesis-driven. The discovery of hydrothermal vents, one of the most exciting things that changed our view of the origins of life, wasn't hypothesis-driven, it was basically accidental. And so what we wanted to try to do is create a program that would help ensure that we're discovering as much as we can and not strictly constrained. The hypothesis-driven science is very, very important, an important component, but it shouldn't be the only approach to ocean science.
Really, finding the Titanic was all about bottom time. Was the main technological shift. For the first 25 years of my life, I was going down physically in deep diving submersibles. And the problem was I was spending most of my time getting to and from work. Just to get to the Titanic is a 2.5-hour commute to work in the morning, 2.5 hours to get home at night. So I was spending most of my time in an elevator. By leaving my body with my spirit and putting it into a robotic device, in the case of the Titanic was the Argo, was having the bottom time. So we went down, we stayed down for days and days and days. And it was really that massive increase in bottom time that gave us the opportunity to finally track her down.
When I started off doing work as a graduate student in 1997, we were doing core sampling to conduct community analysis of the deep sea environment. So the way we investigated the seafloor was to collect box core samples and multi-core samples. These are tubes or boxes of mud that take a punch out of the seafloor, and it's a blind operation. We didn't have a camera on the instrument. We didn't see what environment we were sampling. And the only way we knew what environment we were sampling was basically through some shipboard sea bottom survey work that had been done prior to the sampling.
So what's new is the integration of all of these capabilities, from information technology, from robotics, from telecommunications. So now when we explore the ocean, it's not just the 30 people who are on this vessel as part of the team, it's hundreds or thousands of people on shore, all of whom are saying, well, go deeper, go to the left, go to the right. I know what you just saw. So it's this tremendous integration of new technologies.
My husband and I started the Schmidt Ocean Institute out of a joint interest, his interest in technology and communications, and my interest in the oceans. We could put these things together in this notion of an ocean institute, which could be revolutionary because it's not a brick and mortar place. It's not an institute on land. It's a mobile institute. Everything of value about our institute is on our research vessel. And the idea is we share that vessel with researchers from around the world who need time on ships. And in exchange for that time, that's the philanthropy part of it, we ask them to share their data transparently with other researchers around the world.
You will find that most real advances in understanding the oceans followed rather than preceded technological developments. I mean, in theory, you know, you see movies of a great scientist has a great idea, and he thinks about it, and then you see him shaking a test tube, and then the final act is, yes, I was right on my idea was right. It's not that way, ever.
The early explorers would go out and map. Magellan was going out and mapping. Lewis and Clark made maps as they went along. And you set this framework, the spatial framework for the unknown, and from that you start filling it in with more and more layers as you establish that framework. So our job as mappers, as ocean mappers, is to basically go into those blank areas on the map and fill them in with enough detail to allow us to start understanding the processes to lead to that scientific research.
You might be able to remember, even from the late 20th century, most of the maps that existed of the world and the world ocean depicted the ocean as the vast blue and empty space. There's nothing shown on those maps. One of the big reasons is that even as the satellite photography evolved and we were able to take pictures from space, the oceans remained impenetrable for light or for photography or for any other type of electromagnetic radiation for that matter. So we couldn't gain insight on what's down there.
Since thousands of years, people have mapped the depth of the ocean with just a hunk of lead at the end of a rope. Can you imagine? It's a very long and time-consuming process. About the end of the Second World War, something called echo sounders became more available, and this is something that sends sound out, and you measure how long it takes the sound to go to the bottom of the ocean. It bounces back, and if you know how fast the sound travels, you can time it and figure out how deep it is. And so that became a much more rapid way to measure the depth of the ocean, but you'd only measure one depth over some wide area. About 30 years ago, this new technique called multi-beam sonar mapping or multi-beam echo sounder mapping came along, and that allowed us to measure a wide swath of the seafloor, something like 4 times the water depth. So in 4,000 feet of water, we can measure something like 16,000 feet across the seafloor all at once with many, many accurate depths. And this really changed the way we look at the seafloor. It gave us a much more complete picture over that swath. But even with this new technology, we've probably only mapped about 10% with that technology. So there's 90% still left virtually unexplored in that kind of detail.
I really see the process of exploration accelerating. And certainly the United States is playing a leadership role, but I see other nations now realizing the importance of undersea exploration, particularly since in many cases a huge part of their own country lies beneath the sea, and we have better maps of Mars than half the United States of America. And for other countries, in some cases 90% of their country lies beneath the sea. So I think we're going to see a tremendous expansion of the ocean exploration program, not only in the United States, but globally.
It is said that we know more about the backside of the moon than we do about the bottom of the ocean. Maybe you've heard that. We need to change that. This is our world. It's all very exciting to look out in space and think about life on other planets and where we might go. This is our inner space. This is our world. Welcome to our world, right? And so it's incredibly important that we understand this world. It's going to take exploration. It's going to take mapping.
I think if I remember back, the recommendation of the President's panel was that these programs need funding at a level of something like $75 million a year to maintain that basic level of exploration, and we're absolutely nowhere near that. We're at a very, very small fraction. So the amount of exploration that we do has been very, very constrained by a limited amount of funding devoted towards it.
The sad fact of the matter about funding is that from 2010 to 2014, there was a 25% reduction in federal funding for science across the board, and it's affected everybody. The rise of private philanthropy as a source of funding for basic science has grown in response to that. And I think the reason is, I believe the statistic is there has been $125 billion committed over the next 5 years from private philanthropy. That statistic comes from the New York Times. That is in face of a $40 billion annual budget in 2010 from the federal government that has dropped to $30 billion.
We're willing to pay $2 to $3 billion for a mission to Mars. We've done that a number of times. Yet for the same $2 to $3 billion, we could map our entire oceans at a much, much higher resolution than we have now. So it's really a question of will, fiscal will, political will. And I said, why, if we can map those other planets to that accuracy, don't we owe it to our own planet to map it to the same level of detail?
Coming out of the Second World War, it was the government, the U.S. Navy at first, and then the National Science Foundation, and they were the great purveyors of hypothesis-driven research. They created the ocean science realm that we now occupy. But recently, we have had a flagging of government interest in science and technology. I think it's a huge mistake by the United States and other countries.
As far as funding is concerned, the typical model or National Science Foundation funding model requires that you have a testable hypothesis that's been developed. And in order to create that testable hypothesis, there has to be some level of informed observations as well as exploration that's occurred prior to developing that hypothesis. So it is challenging with the traditional models, but there have been a number of agencies, both federal government and also NGOs and private partnerships that have enabled enhanced exploration in the ocean environment.
Unfortunately, we still don't have enough dedication, we don't have enough people, and we don't have enough resources, either government resources or private resources. I'm a big fan of trying to supplement government-based resources with private resources because I think we need both. And I think the United States is a wonderful example of the merging of both government-based resources and private resources in exploration of the ocean. And I think we can show the way.
The appetite for risk in a government body is far less than it is in private philanthropy. And we're a really good resource for starting investment in private research. We can seed fund lots of things. And the government, I hope, will pick up on some of those things.
I had lunch once with Claire Booth Luce, and it was at her home in Hawaii. And the question came up, why are we so entranced with what goes up in the sky, and why are we having such a hard time getting people excited about exploring the ocean? And she said, well, it's very simple, my dear. Heaven is in this direction, and you know it's in the other direction.
Think about the human relationship with space. and how we would look up at the sky and we see stars and we make pictures out of them, constellations, we map ourselves up there, we tell the human story in the sky. We don't do that in the oceans. The oceans have monsters, right? They have rogue waves and vindictive white whales. They've got mermaids, but those are scary. They're gonna lead you astray. I mean, the ocean is scary. And until we demystify that a little bit, until we can tell the real stories about the magic that we discover every time we dive, people aren't going to relate.
And I've heard this question answered very eloquently by Kathy Sullivan. As it is natural for human mind to be curious about things, it's also very natural to aspire stronger to bigger and more ambitious goals. The galaxies, the stars, the planets that could potentially be habitable are so much more ambitious and so much bigger goal in minds of most human beings that for the most part it is so much easier to get them excited and get more funding for that rather than for ocean sciences.
There's tremendous competition for limited resources in the entire science community. I mean, NASA has a much, much bigger starting place than certainly the ocean agencies. Again, that's a historical fact. So when you start with that discrepancy, it makes sense. I think there are many, many more large corporations that are involved in the space industry than there are in the ocean industry, at least the ocean science industry. And I think that helps very much in terms of NASA maintaining high levels of funding because they involve the private sector at a very large scale that's more difficult for the ocean science community to do. And maybe the most cynical answer is that NASA has had a much better public relations machine than the ocean community. And maybe if we really appealed to the public, they would understand and say, yes, we owe it to our own planet, and we owe it to ourselves to understand their own planet better.
I think the future of exploration has really just begun. I like to say to young people that their generation will probably explore more of Earth than all previous generations combined. So the true explorers that we'll be talking about in 100 years or 200 years are in middle school right now. And so our goal is to try to not only explore and use advanced exploratory technology, but to do those two things in a way that will engage and educate the next generation of explorers. So I find that our exploration program is really important to our nation, particularly exploring the 50% of the United States that's under the ocean and unexplored. But I also think reaching out to the next generation of explorers and engineers is as important.
What are the underexplored parts of the ocean? There are several. First, there are regions that you'd expect to be underexplored, and they are. For example, the Arctic. Under the ice in the Arctic, there's still been very little real exploration in the Arctic. In the eastern and southern Pacific, there are vast areas that are unexplored. The deeper parts of reefs, scuba divers may go down 80 or 100 feet or even a bit deeper on reefs, but reefs can go down several hundred feet. And those parts of the reefs are very, very little explored. And then there are the vast midwaters, the largest habitat by volume on Earth. And at sea, we've tended to look at the surface, and then we kind of zoom down and look at the sea floor. But there's all this water in between, and we sort of run these express elevators. And so these vast midwaters are also little explored.
It isn't just the top, it isn't just the bottom, it's that living ocean itself. It's the liquid part of the ocean that presently represents the greatest gap in terms of our understanding of how the planet functions. It isn't just a continuous, homogeneous system. It's layered with light, layered with temperature, layered with differences in salinity, layered with differences in the level of acid or basic nature, layered with kinds of life, some that prosper up in the light, some that are definitely wedded to darkness.
One huge question that is still unanswered and will require lots of work to understand is the process of ocean acidification and absorption of carbon dioxide from the atmosphere. How is it captured in the ocean? How is it stored in the seafloor? How is this process regulated? And to understand this, in fact, scientists are now realizing you may need to be able to track individual animals and the products of their metabolism to see what really happens with those pellets as they propagate through the water column. What happens with those animals? Who eats those animals? How they react to changes in their environment in terms of function of consumption and absorption of carbon dioxide and storing it at the seafloor.
I think that we have a long way to go in reaching the public about the nature of our relationship with the oceans, why they should care about the oceans. Institutes like the Aquarium of the Pacific do an amazing job of outreach and education, but they're nonetheless discrete institutions. And the public has to go there, they have to have an interest to begin with. There's a step that has to be taken. What I would love to see is the interweaving of ocean information into basic science education everywhere, right? So that it isn't the case as it was when I was a child, that things were in silos. If you were an ocean researcher, you had nothing to do with an astrophysicist. You had nothing in common. You'd never even crossed paths. Now I think those boundaries are breaking down. We have more to talk about across the board when we look at life on Earth.
So there is still lots and lots for us to learn and understand about the ocean, which may require development of new systems that can be in the ocean for a longer time. Even with the advanced robots these days, robots can only stay in the ocean for as long as the engineer that is supporting this robot is able to provide the services. Even if it's over satellite, it's not very scalable these days. But how about being able to provide robots with sufficient intelligence to be able to operate autonomously as necessary, for example, in the Southern Ocean over the span of a year, or maybe several years? How about developing robots that can track individual animals and observe their behaviors and develop their understanding of their biology over lifespan of that animal? So those are still questions that will need to be answered over the next decades with the development of new technologies, monitoring techniques, information assimilation analysis, that I see lots of work requiring all these tasks to be completed.
We should be able to have the entire ocean mapped at what I call high resolution, at kind of 100-meter type spacing in the deepest part of the ocean, or even less. And as I said, I did the calculation using a very expensive ship rate, a typical deep sea ship rate, $35,000 a day. It would end up costing about $2.5 billion. That sounds like an exorbitant amount, but again, I think we owe it to ourselves, we owe it to this planet to understand this planet as well as we understand other planets. So I would like to hold out that goal that maybe before I die, we'll see a national effort to map our own planet at the resolution that we've mapped some of the other planets.
I've started an endowment at my university on something we call rapid response. I think scientists have now got to respond to natural disasters, to earthquakes, to volcanic eruptions, to tsunamis. And we've got to understand these major punctuated events because of the impacts they have on us as a species and on the oceans as well. We've got to put more technology in play. So that means we've got to have resources in play. We've got to have dedicated people who are not necessarily in it for the money. They're in it for the fun, they're in it for the excitement, they're in it for rubbing elbows with like-minded, passionate people. We need more of them.
I believe that ocean exploration is a primary or fundamental part of the scientific method. So I believe that ocean exploration will continue to be a major part or play a major role in ocean science. Where we have challenges is basically directing that ocean science and making it useful to the public, bringing that information to community scientists at home, and enabling and educating our next generation of marine scientists.
If you take a breath of air and then you take another breath, you have to thank the ocean for one of those breaths, because half of the oxygen we breathe on the planet comes from the photosynthetic operations of phytoplankton. Microscopic, never going to see them. Nobody's going to run and visit them at the aquarium, but they are vital to our support and our future. And this is the kind of learning we've got to start communicating to children, to adults, to everybody.
Oh, it's a great field, very exciting, lots of exploration to be done. I think the next 100 years are going to put us in the limelight because of the climate problem, and the oceans is maybe the most important element of climate change.
I see ocean exploration as a bit like the modern generation of cathedral building. Growing up in Europe, I was steeped in awe of this idea of families in the town I lived in just before I moved away was near Salisbury. So Salisbury Cathedral has the tallest spire in the UK. But it was true of all those cathedrals that grandfathers would lay the foundation stones and work the rest of their career on building this cathedral and see it rise a certain distance. Their children would then grow up and spend all their adult life working on those cathedrals, and it would be the grandchildren generation that would actually finish off and see the spire topped out.
So we have to learn how to take a more long-range point of view, and it's possible that we can. And I think that will be a very exciting time to participate in. And there are lots of very good people who are devoting their life to making that work.
America is the greatest maritime nation on this planet, and has been, I think, since the beginning, but certainly is now. If you look where we sit right exactly in the center of two great oceans and a couple of seas. We have the Gulf of Mexico to the south, the Arctic Ocean to the north, the Pacific and the Atlantic. And we're completely surrounded by that. They have, in a sense, been for us, if you use the electricity analogy, they have been an insulator against aggression, and they have been a conductor of trade. So as the greatest maritime nation in the world, we really have a responsibility, an obligation for our own welfare to understand what's going on in the broad ocean, globally, for all kinds of reasons, for national defense, climate, economic reasons. But also, this is something that, it turns out, excites young people. If a young person goes to an aquarium or to a science center someplace and sees what has come from ocean discovery, they get excited. I've seen this myself at any number of aquaria. Recently, I was at the Aquarium in the Pacific, and I stood behind a young, maybe a 6-year-old young boy, and he was so excited that he drew his family in. Well, this is a great experience because they remember these things. And when this young man gets to be about in the 8th grade, he's going to make a decision on his life, whether he's going to go towards science or he's going to go towards something else, right? None of us make that decision about the National Football League. We love it our whole life, but we do make a decision in our life about whether we go towards science or not. And these kinds of experiences where you bring this discovery, these exciting things to people that they have never seen before, excites them, it gets the support of their family, and we're more likely to at least have an informed citizenry that can vote on important ocean issues. But we'll gain more scientists, young scientists and engineers that will pursue a STEM career their entire life.